This video is an introduction to Chapter 10, and we just really need to review two concepts from geometry in order to be successful in the Chapter 10 content. So the first thing that I'd like to review with you is trigonometric functions. You learned about three trig functions in geometry, which are sine, cosine, and tangent. Or you may remember SO, CA, TOA. It turns out that there are actually 6 trig functions, which you'll see later on in our notes. But for now, in this video, we're just going to focus on sine, cosine, and tangent. In order for sine, cosine, and tangent to be used, we must have a right triangle. And in that right triangle, we're going to have a reference angle, which we denote as theta. So theta, right there, is what we call our reference angle. From the reference angle, you would want to identify the opposite, adjacent, and hypotenuse length. The hypotenuse is always directly across from the 90-degree angle, and it's also the longest length. Now, you don't always have all 3 sides, so you can't always tell just based off of the side lengths. But if I take a look here, it's 3, 4, and 5. 5 is the largest length, so I know it's the hypotenuse. Or, again, it's directly across from the 90-degree angle. If this is my theta, my reference angle, the opposite will be directly across from, or opposite to, theta. And the adjacent length is the leg that is right next to it, or side by side. So that would be my adjacent here. If instead of my theta being here, and it was here, so I'm going to use a different color to denote that. So if this was my theta, the hypotenuse would remain the same. However, the 3 would now be the opposite length, and then the 4 would now be the adjacent length. So you must pay attention to where your theta is located. I'm going to start with this example right here. We're going to find the sine, cosine, and tangent of theta. So I want to write sine of theta, cosine theta, and tangent theta. So remember, SO, CA, TOA tells us how to write our trigonometric ratios. Sine is opposite over hypotenuse. So if this is my theta, opposite is 15, 39 is the hypotenuse. So I would put 15 over 39. Now if we can, we'd want to simplify this ratio. Both numbers are divisible by 3, so it becomes 5 over 13. Cosine of theta is adjacent over hypotenuse. So the leg that is right next to theta is the 36. And the hypotenuse we already said is 39. Once again, you'd like to simplify your ratio if at all possible. And we can once again divide by 3, leaving me with 12 over 13. And tangent is opposite over adjacent, so 15 over 36. Once again, if you can simplify, you would like to. It is divisible by 3, so I'm going to put 5 over 12. Once again, we want to write sine, cosine, and tangent. If my theta, my reference angle is right here, opposite would be 30, 16 would be adjacent, and 34 would be my hypotenuse. Just going over that once again. The hypotenuse is always directly across from the 90-degree angle, or it is the largest of the 3 lengths. Opposite is directly across from theta, and it's going to be one of the legs. Adjacent is the leg that is side by side or directly next to theta, which in this case is the 16. So now we're ready to write sine of theta, cosine of theta, and tangent of theta, simplifying our ratios if we can. So sine is opposite over hypotenuse. That would be 30 over 34. I can simplify this. They're both divisible by 2, so it gives me 15 over 17. Cosine is adjacent over hypotenuse, so 16 over 34. Once again, we can simplify it. Both of those numbers are divisible by 2, so I get 8 over 17. And then tangent is opposite over adjacent, so 30 over 16. Once again, simplifying, both are divisible by 2. I get 15 over 8. Another concept you should have learned in geometry was about special right triangles. We have two special right triangles, a 45-45-90 and a 30-60-90. In a 45-45-90, the legs are congruent, so you can see how I have x and x. We're just going to write congruent legs. And then the hypotenuse is going to be the length of the leg multiplied by root 2. So hypotenuse is root 2 times the length of the leg. We can underline that right there. The 30-60-90 has different rules. So the 30-degree angle, our smallest angle, is opposite to our shortest leg. The 60-degree angle is opposite to our long leg. And then, of course, we have our hypotenuse, which is across from the 90-degree angle. So in a 30-60-90, if you have the short leg, we can easily find the other two lengths. The longest leg is the short leg times root 3, and the hypotenuse is double what the shortest length is. And it all says that right in here. But the best way to try these problems is just to practice with examples. So I'm going to start with number 1. The first thing you want to do is identify what type of special triangle you have. This is a 45-45-90. So I know two things. I know that I'm going to have congruent legs, and I know the hypotenuse is that leg times root 2. So I know that these legs are congruent, meaning if this length is 6, then this length is also 6. And all I have to do to find the hypotenuse is multiply the length of the leg times root 2. So 6 times root 2. And that's it. Pretty easy. Number 2. I have a 30-60-90 triangle. And I gave you the shortest leg. Remember, that's the leg that's opposite the 30-degree angle. Since I gave you the shortest leg, it should be easy for us to find the other lengths. The longest leg, we can see, is the shortest leg times root 3. So I'm just going to put 12 times root 3. The hypotenuse is double what the shortest length is. So it's 2 times 12, or that means it's 24. These were the easiest type of problems I could give you. However, it's not always going to be that nice. If we take a look at number 3, this is a 45-45-90. So I know that the legs are going to be congruent, but I did not give you the length of the leg. Instead, I gave you the length of the hypotenuse. So I want to find the length of the leg. I'm just going to call that x. I know that the hypotenuse is equal to the leg times root 2. So 10 is equal to the leg, which I called x, times root 2. I want to solve for x. In order to do that, I need to divide each side by the square root of 2. So x equals 10 over the square root of 2. Remember, we are not allowed to have radicals in the denominator. So you must rationalize this expression by multiplying by root 2 over root 2. By multiplying by root 2 over root 2, I'm going to go across the top, across the bottom. I get 10 root 2 over the square root of 2 times 2 is 4. And notice how the square root of 4, we know, switch this down a little bit, is 2. So really I have 10 root 2 divided by 2. And we can simplify by dividing the 10 by 2. I can't divide the root 2 by 2 because this is underneath a radical and this is not. This is a whole number. So I can only combine my constants by dividing. So 5 root 2. All right, number 4. We have a 30, 60, 90, and I gave you the longest leg. Remember in number 2, when I gave you the short leg, it was really easy, but now I gave you the long leg. I know that the long leg, so 3, is equal to the shortest leg times root 3. So we'll just call this y. Since I already used x, we'll use y. So y is the shortest leg times root 3. And I solve for y. Divide each side by root 3. We get y equals 3 root 3. You need to rationalize by multiplying by root 3 over root 3. That gives me 3 root 3 over the square root of 9, which is 3. 3 over 3 is 1, so I have 1 square root of 3, or just square root of 3. All of this should be easy for you because that's just basic algebra that we already reviewed. The hardest part is just getting everything set up. So at this point, I'd like you to try the homework and use these rules to help you.